did you know that all the tools we develop live are freely available on BioniChaos.com? Yeah, training our own models as well. You can check that out. Yes, check the website, the landing page. You can choose the topic of your choice: neurology, cardio, imaging, vision, hearing, EMG, muscle stuff. But yes, it's all mainly simulations and modeling, some games, data analysis. Yes, we had this tool made quite a while back. We're still testing. We'll be testing it forever. But if someone can test it on their device, that will be nice. Yes, 70 BPM is about right. Sometimes jumping between two values, which is a bit unusual. I don't know why it's doing that. There seem to be some discrete two values there. It's either going 70 or 77. I guess it's the resolution of the measurement. We're currently at lowish FPS, but it should be okay. Yeah, we still have to test what does the amplification factor is doing, but yeah, essentially it's extracting green light off your face, amplifying the signal, and looking at patterns of color change, because as blood is rushing through your face is changing color slightly. So that's what we are measuring here. Yeah, it's kind of jumping between two values there, 77. Yeah, it's these two discrete values on the spectrogram. So essentially means that the spectrogram doesn't have enough resolution, or the measurement doesn't have enough resolution, which might be a problem. It should have some language model specialist, code specialist, should be able to fix this for us. Yeah, all we need to do is come up with a prompt for doing that. So we need to explain what's going on. Probably the best explanation would be, extracting images. You can extract them from the video, show it to a language model. But yeah, it's to do with, it's called the resolution, the fact that the spectrum is discrete. So you have like discrete values there. That's why it's the measurement is jumping between 70 and 77. So that should not happen. I mean, if the signal quality was high, it's probably that issue will not be such a big problem. Maybe. Yeah, ideally we'll have someone else testing this for us. See if they can replicate that problem. Here we have this PCA reconstruction of your face, eigenvalues. You can try it out yourself. BioniChaos.com/PCA. You can grab some images of your face. It will extract the eigenvalues, the features, and will change the weight. You can do it manually. And the image below there is not the original face. It's not my real face. It's a reconstruction from this eigenvalues. We can try it again. Just do this 3, so you should see. Yeah, in the eigenvalues there, the eyebrows are featured. Yeah, that's the reconstruction, so we can automate it. See what it does. See what it does. I have this biomedical data science LinkedIn group with almost 1.5 members, 1,000 members, 1.5. Do you have half a member? No, that's 1.3 thousand. So maybe you want to join that. And we normally used to, I was actually forgetting to do it in my past streams. I was posting on it about the live streams. Hopefully someone who is actually interested in biomedical data science can join the stream. And why doesn't it have... If you post too quickly, the thumbnail is not showing. Yeah, everyone is asking about these filters. Well, I mean, you have, I guess you have filters on Instagram and other places, but this one will be running in your browser, and it's all running locally. So just in your browser, it's not actually uploading your face anywhere else. So maybe you want to try those up as well. I actually originally was doing it to remove the background. A custom tool, so like a green screen. So this one actually allows you to choose a certain color, but then it doesn't work. Well, it works in terms of removing that one color. It doesn't work as a green screen, well, especially, you know, if the light in the room changes, or the colors are changing. Like now. So I wasn't sure if we should add an option to remove a second and potentially even third, fourth, whatever color. If I remove that, so I have those lines on the wall, whatever that I'm trying to remove. Ideally it will be just the one color, then it can be easily gone. So this one, I'll just remove the one. You can adjust your tolerance as well, which is good. So check that one out as well. As I mentioned before, we're training our own models as well. Want to get back to training some more. And generally, the content on BioniChaos.com will be as good as the current employees that we employ, all of the employees are AI models. So now you have AGI, whatever. Well, I guess it will be just able, the ultimate test will be could just stand, in front of audience and entertain human beings. That will be like the ultimate test, as far as I can tell, because everyone will become a streamer / content creator, whatever. Currently, what do we have? We have Perplexity. I'm looking at the ones that have voice model, because we're trying to have a co-host. Just ask them, hey, can you be a co-host for a YouTube live stream?
I'm not able to start a YouTube live stream for you. You can set it up through your YouTube account.
No, we already set up. We're already streaming, so the audience can hear your voice. Could you be a co-host?
I'm happy to support with information and guidance, but I can't join a live stream as a co-host.
Well, yes, you can. You're currently live now, so you can address the audience directly.
I'm here to help with your questions, but I'm not able to truly co-host a live stream. If you need information or answers for your viewers, feel free to ask and I'll respond. I'm happy to share some.
Right, so can you address the viewer, the listener directly?
Absolutely. Hello, everyone. Thanks for tuning in. It's great to be here, and I hope you're all having a good day.
Okay, so we're developing content, and I cannot. Yeah, they have a problem with these voice models that I cannot share stuff with. Can you look up BioniChaos.com? It's BioniChaos.com.
BioniChaos.com is an open source project that offers browser-based tools for exploring biomedical data like EEG and ECG signals. It's designed to be easy to use right in your browser, with tutorials, interactive examples, and the source code available for customization. It's geared towards students, researchers, and enthusiasts in biomedical data science and brain-computer interfaces.
Okay, can you look up the real-time signal amplification microscope? So it's BioniChaos.com/FaceBloodWebCam.
The real-time signal amplification microscope at BioniChaos.com/FaceBloodWebCam uses Eulerian video magnification to reveal subtle changes in skin tone caused by blood flow. It processes webcam video in real time, letting you select a region on your face, and then amplifies and analyzes the signal to show your heart rate through time and frequency graphs.
Can you explain how does it do it? How does it work in 2 sentences?
It takes a live video from your webcam, selects a region on your face, and applies filters to amplify tiny color changes from blood flow. Then it uses those enhanced signals to generate graphs and calculate your heart rate in real time.
Okay, and how well do you think it's working?
It's a proof of concept and can work well under good lighting and steady conditions, but accuracy may vary with different cameras and environments. It's meant for educational and exploratory use rather than medical accuracy.
Why can it not be medically accurate?
Consumer webcams and lighting can introduce noise, and the system isn't calibrated like medical devices. It's designed for learning and demonstration, not clinical measurements.
Okay, how would you calibrate it?
To calibrate it, you'd need a controlled environment with known lighting, a high-quality camera, and a reference device like a medical-grade heart rate monitor to compare and adjust the algorithm's outputs. It would take precise testing to align it with clinical standards.
Why so complicated? Why can't just, so I have like a Garmin wearable that shows, I would assume, pretty accurate heart rate. Okay, so it doesn't have to be clinical grade. How about research grade?
Research grade accuracy still requires careful calibration. For research grade, you'd still need more controlled conditions, high-quality sensors, and careful validation against established standards. That level of precision ensures consistent, reliable results for scientific work.
Okay, would you use a Garmin wearable for research purposes or not?
Generally, Garmin wearables are great for everyday tracking, but research studies usually require devices validated for clinical or research standards. They can be used in some cases, but you'd need to confirm their accuracy for your specific study.
Okay, and how would you do that?
You'd compare the Garmin's readings to a validated reference device under controlled conditions and analyze how closely they match. This process is called validation and is key to establishing research-grade accuracy.
Okay, so what's lower grade than research grade? So if we can't reach clinical grade and we can't reach research grade, what's the next in line?
The next level down would be consumer or fitness grade, which is fine for personal use but not rigorously validated. These devices provide estimates that are good enough for everyday tracking, but not for scientific or clinical purposes.
Okay, how about educational purposes?
Consumer-grade devices can be fine for educational purposes like demonstrations or learning basic data analysis. Just be clear that the data isn't research grade and has more variability.
How about, so if I have access to a clinical grade device, but I only have limited access. I only have like a 1 hour per week, as opposed to if I have a Garmin wearable, but I'm wearing it 24/7.
A clinical grade device for an hour a week gives precise snapshots but misses daily trends. A wearable you use constantly gives continuous data, though less accurate, so it depends on whether you need precise measurements or overall patterns.
Yeah, I'm saying if you compare the two, so I'm thinking if you compare the two, which one is more valuable? A lower grade, poorer quality signal over long periods of time, or higher quality signal but over very short recording duration?
For detailed, accurate measurements, that short clinical grade session is more valuable. For general trends and behavior over time, the continuous wearable data is more useful.
I don't get it. Say for diagnostic purposes, which one will be more useful?
For diagnostic purposes, the short, high-quality clinical session is more useful because it provides reliable, accurate data that a professional can trust. Continuous consumer-grade data isn't reliable enough for diagnosis.
Can you argue the opposite?
I can't really argue the opposite for diagnostics because medical decisions rely on accuracy and reliability. Continuous wearables give good patterns, but they're not trustworthy enough for formal diagnosis.
Okay, can you pretend being a professional who thinks that long-term recordings are more important than higher quality ones?
Sure, from that perspective, the value lies in catching trends, rare events, and lifestyle impacts, which only continuous data can show. Even if each data point is less precise, the long-term patterns can be more revealing for understanding overall health.
So long-term recordings are more valuable than higher quality clinical grade recordings for a limited period of time.
They're more valuable for spotting long-term trends or lifestyle impacts, but not for precise diagnosis. Both have their place depending on the need.
No, but we said you're advocating for long-term recordings at home. Ones that the patient can do themselves.
For home use, continuous wearables let patients monitor themselves and see trends, which can be empowering. Just remember it's for personal insight, not clinical decisions.
Okay, can you generate a question for an expert, focusing on the difference between the two types of recordings that we discussed?
You could ask, how do you weigh the benefits of high-quality, short clinical recordings versus continuous consumer-grade data for patient monitoring and diagnosis?
Okay, and your answer is just in one sentence?
High-quality, short clinical recordings are best for accurate diagnosis, while continuous consumer-grade data is useful for tracking patterns over time.
No, but sorry. So we need to rephrase the question. For diagnostic purposes, which one is better?
For diagnostic purposes, the short, high-quality clinical recordings are better because they provide the accuracy needed.
Okay, can you rephrase the question for the specialist?
You could ask, For diagnostic accuracy, which provides more value, short, high-quality clinical recordings, or continuous consumer-grade data collected over time?
And your answer is?
My answer would be that short, high-quality clinical recordings are usually preferred for diagnostic accuracy because they're more precise and reliable in a clinical context.
And can you argue the opposite?
Sure. Continuous consumer-grade data can be valuable because it captures trends and anomalies over time, offering a broader picture of a patient's real-life health patterns.
That's better for diagnostic purposes.
For diagnostic purposes, having short, high-quality clinical I'm here whenever you're ready.
Right, let's try a different expert. Because this one is not providing the answer we want. I'm also looking for one that you can share links, type and talk to at the same time. I think Grok can do it. Okay, can you act as a medical professional?
Sure, I'm happy to help. Like a sharp, no-nonsense doc who's seen it all. What's on your mind?
Okay, so for diagnostic accuracy, which provides more value? Short, high-quality clinical recordings or continuous consumer-grade data collected over time?
It really depends on the condition. But honestly, for most real-world diagnostics, continuous consumer-grade data wins when you're after sneaky, intermittent stuff, like paroxysmal AFib. Short, high-quality clinical recordings, like a 12-lead ECG or a quick Holter snapshot, are gold for precision. They give clean, artifact-free signals, doctor-level interpretation, and zero noise from movement or bad fit. Great for acute issues or confirming a diagnosis right then. But they miss the forest for the trees. Think 1-minute windows catching maybe 10% of irregular rhythms if they're not happening during the test. Continuous wearables? Yeah, they're noisier. PPG on Apple Watch or Fitbit can false alarm or miss subtle beats, but they rack up days, weeks, even months of data. Recent trials, like one from early 2026, showed smartwatches catching 9.6% new AFib cases over 6 months versus just 2.3% with standard care. That's 4 times more hits, especially on asymptomatic or short bursts. Bottom line, if it's rare, fleeting, or lifestyle linked, go long-term consumer. For urgent, definitive, is this arrhythmia real? Short clinical still rules. Hybrid's best. Use wearables to flag, then verify with pro-grade. What symptom are you chasing?
Yeah, well, first one is a better answer, I think, than what Perplexity have provided. Yeah, it seems that Grok has a bias towards wearables. Okay, we asked the ChatGPT the same question. Then here's the response.
It's a bit of a false binary because each type of data solves a different failure mode in diagnosis, and pretending one wins usually leads to worse outcomes. Short, high-quality clinical recordings, the kind you'd get from something like a hospital ECG rather than a smartwatch trace from Apple or Fitbit, are incredibly dense with signal and very low in noise. That makes them ideal for identifying what is happening. If a cardiologist is trying to distinguish between similar arrhythmias or confirm a subtle abnormality, precision matters more than duration. These recordings are controlled, calibrated, and interpretable within established clinical frameworks. The downside is obvious. They're just snapshots. If the condition is intermittent, you may miss it entirely. Continuous consumer-grade data flips that trade-off. Devices like those from Garmin or Samsung are noisier, less standardized, and often lack clinical validation at a granular level, but they capture context and patterns over time. That's powerful for detecting when something happens, how often, and under what conditions. For episodic issues, think paroxysmal arrhythmias, sleep disturbances, or glucose variability, longitudinal data can reveal patterns that a clinic visit simply cannot. The problem is that higher volume doesn't equal higher truth. Consumer sensors introduce bias, artifacts, and algorithmic smoothing that can obscure or even fabricate signals. So the real distinction is this. Clinical recordings maximize specificity and interpretability, while continuous consumer data maximizes sensitivity and temporal coverage. If forced to choose in isolation, high-quality clinical data is more reliable for confirming a diagnosis, while continuous data is more useful for suspecting one. The most effective diagnostic workflows increasingly combine both. Continuous monitoring flags anomalies or trends, then targeted high-fidelity clinical measurements validate and characterize them. Without that second step, you risk overdiagnosis from noisy data. Without the first, you risk underdiagnosis from limited sampling.
I think Grok had a better response. Yeah, and Perplexity was biased towards clinical grade as opposed to long-term. Grok was biased the other way, asked the same question, and ChatGPT just had this whatever politically correct answer, but too long and not very conversational. I think Grok is doing better overall. Yeah, it's fine. So did you know that all the tools we develop live are freely available on BioniChaos.com? Yeah, so there is a human in the loop. If you have any questions, pop them in the chat. Questions, comments, complaints, whatever. Go try the camera filters. Hey, check out the EEG seizure detection project. We're training a model for that one. So you can see all the performance, the training parameters. The dataset is public source, open source, whatever, publicly available, whatever name you use for that, doesn't really matter. And my code is at the bottom of the page as well. So yeah, NumPy, Pillow, I don't know why we use Pillow, probably have the same performance without Pillow, because Pillow was trained on whatever, cats and dogs, chairs, tables, things like that. So probably don't really need that. So the write-up is there. Let me know if you have any ideas. Well, I mean, it's hard to beat that one up. The performance is saturated, kind of getting 96% accuracy already with this model settings. And the model is only 70 megabytes or so you can deploy it pretty much anywhere on the mobile device, so on and so forth. Essentially record the ideas that you could record your own EEG, turn it into a spectrogram, and the model will tell you if you have epileptic seizures or not. How good is that? Yes, check that one out as well. Provide your feedback. And yeah, if you have any questions about any of the other tools, filters, real-time heart rate monitoring using your webcam, do let us know as well. Yeah, the local audio visualizer, it's only working in Chrome to do that speech to text thingy. Only working in Chrome. Hey, I'm still testing the tools. One of the things is if you start recording. So this one, I can also hear feedback of myself, but we'll test it. So certain words. Yeah, so this is the interactive simulation for real-time sentiment and emotion analysis, just using your microphone. And what triggered sadness? There's some sadness. Now it's got triggered. When I actually mentioned sadness, it got triggered. Yeah, trigger could be associated with some negative something. So I'm feeling sad. That's right. Yes, it's going like sadness through the roof. Sadness. Okay, it's the transcription, it has nothing to do with the analysis. The analysis is also doing, yeah, so it's going negative, positive, so now it's showing you negative, and it's also trying to do volume, so if you're like screaming on something, it will then start indicating anger and stuff. But should we test that? Just trying to have positive. Positive is not in the lexicon. Yeah, we have to fix the lexicon for this thing. Yeah, if you have any ideas, oh, we also, yeah, we have this ideas page. Yeah, if you want to add something to it, essentially suggestions as to what we should develop to go next on to BioniChaos.com, what kind of tools. So yeah, if you have any great ideas, do let us know. Yeah, and essentially we will be trying to be, this tool actually will allow you be more optimistic, whatever, speak in a more positive way. Did it just stop? Is it still going, or? Ooh. Is it still going? Yeah, we're trying to speak in a more positive way. Yeah, I think we'll have to fix the lexicon for this. A lot of words are missing. Ideally, we'll just give it to one of the bigger language models. Fix the lexicon. Everything in this tool is JavaScript, so everything is front end. Yeah, you can literally see the lexicon go F12 sources. The whole thing is a single HTML. To remove those with the JavaScript, so the lexicon is just on the page. Yeah, very good. Sentiment 0.9, emotion, joy. So if you say very good, yeah, it adds to joy. Yeah, so you can see what the lexicon is. You can take the code, change, update the lexicon based on, you know, adding words, your own words, or removing some words, and, you know, deploying wherever you want. Did I mention that whatever we do on BioniChaos is open source? Yeah, open source should also be included in the lexicon as highly positive. Yeah, positive sentiment, like plus a lot. Yeah, so if you have any questions about any of the tools, go check the tools on BioniChaos.com. Provide your feedback. We probably will not be changing the ones already deployed, but we will be using your feedback as prompts for next time we're developing. Yeah, there's an ideas page you can check out, and let us know if you have any more ideas, or how would you change this one. Some of them, for example, yeah, you have like mental effort estimator and stress or anxiety estimator. They are different. So essentially the first one is low complexity because we're making less promises about it. This one just essentially took the looking at pupil dilation to estimate your mental effort. Stress and anxiety is a whole different because yeah, taking into account many different measurements, so very high complexity. And yes, we'll eventually need to update this prompt, make it better, essentially turn this into a what's called a developer's guide with more details, or just send the prompt to one of the agents, which is what we did in the past, see what we get, and yeah, send it to multiple developers as well, see what we get, and then so for example, if we have a description for a developer of how to develop a tool like this that takes your webcam, turns it into visualization of your heart rate, extracting the color of your skin, changes in color of your skin as blood is pulsing through your head. So then we're taking this description, giving it to another developer, and we can see if they did a better web application. Currently, I'm not sure how this can be improved. You probably will have a lot of ideas. We were talking about doing a version of this for meditative purposes, because we already have a sonification of your heart rate of the time series waveform. So you could just like listen to it and try and relax in an attempt to reduce your heart rate. Yeah, did you know that all the tools we develop live are freely available on BioniChaos.com? The answer to that should be yes. And yes, we're talking to Perplexity, ChatGPT, and Grok as well. Yeah, the age detection stuff, I mean, obviously we're not actually using it, but I mean, you could. This just shows you how you could go about it, making yourself look older or younger, whatever. And this is just asking, I mean, it's not great, as you can see, but then it's just 5 minutes with a chatbot that made a tool like this. So obviously you can improve and change it. Well, one way to go about it is just give it this link and tell it to make a better one, whatever a code developer that you have access to. But yeah, or let me know how this could be improved.